Welcome to a pre-recorded webinar, Real-Time Production Monitoring for Continuous Improvement. The speaker for this presentation is Stephen Morse from DELMIAworks. We hope you enjoy the webinar.
Good afternoon, everyone, or good morning, depending where you're located here. My name is Stephen Morse. I'm one of the Rose portfolio managers here, and I'm going to be guiding us through this trip that we're going to take today. So let's go ahead and jump right in. A couple things here on the what is this all about, etc. So let's take a look here. Some key takeaways is we're going to learn what the real-time production monitoring applications and hardware are capable of. So giving you a nice solid overview of what you can do with real-time and give you an idea how you can improve your business processes. Also going to learn how to reduce data entry. So why is real-time so important to your organization? Well, we'll take a look at how we can reduce that data entry and gain some efficiencies across the entire organization, as well as, a little conversation here about how OEE can drive your continuous improvement processes. So a bit about me here. Okay, so who am I? Like Leah said before, I am one of the DELMIAworks Rose portfolio managers. So what does that mean? I'm a product manager. I'm one of the people that get to decide and help decide, what goes into the software, what does our future look like, etc. So it's kind of fun. I'm on the front end of R&D, making the plans, and R&D, of course, are the ones executing that. From there, just in case you guys are not aware of who I am, I've been with the company over 14 years. So the first 10 years of that was in professional services. So I was the part of the group that came in and with a new customer or an existing customer and implemented the software or helped you look at your processes and make changes to make improvements in your overall business, how your business is operating and stuff. And the past 4 years and growing, I've been spending my time in R&D. So I've taken that knowledge that I gained in the field and actually at one point in time as a customer and that other industry experience and bringing that knowledge into the R&D team to help us, build products that make your lives better and make your operations run smoother. Just a little bit on the manufacturing side here, I actually grew up in Tier 1 automotive. So I have been in the automotive industry for a very long time. And as each year passes, that time keeps growing longer and longer. And then over time, working with customers and prospects, et cetera, started to learn a lot more about medical device, aerospace, and consumer packaging. And the funny thing is there's so many commonalities between those three industries. There's a lot of similarity to what automotive does. If you think about it, some standards are set in automotive and it affects those industries. Some standards are set in aerospace and it affects those, et cetera. So there's a lot of cross-pollination of similar aspects of the operations with that. Currently, I'm really focused in on API and the technology stack. So that's kind of where my focus area is right now, helping us, innovate with new ways of, interacting with the system, new technology coming down the line. I help support my coworkers here, and I actually have a little bit of operations too. And as you can imagine, because I grew up in automotive, I love inventory accuracy, which is why this topic is really kind of links right into that passion for inventory accuracy and actually links in with both Kaizen and TPS. So, and little fun fact, just so you guys know, I do love to cook. So if you ever want to talk about food at some point in time, hit me up. I'm always happy to talk about food. So let's hit the agenda. So what are we going to talk about today? Little overview of what real-time production monitoring is, okay, and why real-time really sets the tone for why do you want to do real-time versus paper? Okay, what's the benefits over real-time versus paper processes? Continuous improvement in OEE. I'm going to dig into that a little bit too and explore why real-time can really give you some insights into what's going on in your production floor and short-term make some major gains and long-term, drop some dollars back to the bottom line and improve your overall customer experience for your customers as well as for your employees. And then we'll do a little wrap-up here and head right into the Q&A. So what is real-time production monitoring? So how do we at DELMIAworks define that? So really what it is, it's your production resources connected to the ERP system. Okay, so what do I mean by that? I'm taking information from your production floor. So it could be a machine or it could be a person, and I'm connecting that data into the system to automate, getting that production data, okay? So things, think about it like, your cycles and cycle time data, uptime and downtime information, good parts, bad parts, hopefully more good parts than bad parts, and live data that can be viewed just about anywhere. So what I'm really doing then is is taking information that typically gets entered later on in the, at the end of the shift or maybe at the end of a production run, and I'm connecting that information and making it available in real time. And why would I want to do this? Why would I want to even think about real-time production monitoring? Well, it really simplifies data entry, it simplifies the data collection, and it eliminates, not 100%, because nothing in life is ever 100%, but it definitely helps eliminate a lot of that, that noise in the background, data entry errors, etc. So that's what real-time production monitoring is really about, is collecting information and automating that data collection as much as possible so that we're building production reports and we're providing connectivity from data from end to end. So what are the components that make up real time? So here I am, I'm jumping in, I want to start using real time. What does that mean to you guys? So there's a couple main components, okay? The foundational piece is what's called a real-time work center. So the real-time work center allows that connection between the ERP software and a work center on the production floor, okay? And that is the ability to collect information based upon what's running on that particular work center at a particular given point in time. Now, there's two concepts to be aware of really quick here, and we'll dig in a little bit further here as we move along, between what's called a signal work center or a non-signal work center. And the benefits you get from both single or non-signal are very much on par with each other. The biggest difference is when you have what's called a single real-time work center is you're pulling information directly out of the machine, okay? So the machine itself is providing not all of the data and the information, but a lot of the data and information. The non-signal is using other resources such as potentially scanners, production, on the floor production reporting as opposed to production reporting in the back office, et cetera. That's providing what's called non-signal real time. Now they both provide the same value. You're collecting data in real time and you're driving a lot of information throughout the system. Now on the hardware side, if we're talking about a connected work center, so we're doing what's called a signaled work center. So I'm getting that heartbeat, that information directly from the machine. I'm knowing, when is the machine cycling? When is the machine not cycling? Is it cycling fast? Is it cycling slow? And all those other various pieces of information. That's coming through our hardware connection. And for us, there's three major ways of accomplishing that connection. One, what's called the wired connection. So you literally are taking a wire from the machine into a control box, connecting that control box into the network, which is providing data into the system. You can do the exact same similar thing where instead of using a physical wire to connect that piece of equipment on the production floor into that smart box, I can use a wireless connection. So I'm using what's called a wireless mode. I'm wiring that into the machine. I can have that, generate the packets, send the information to that wireless receiver. And again, I'm getting that details from the machine. There really is fundamentally no difference. It's just one requires a wire and one is just a wireless application. And of course, there's pros and cons to both, right? Wireless is a little more expensive up front. However, the benefit is if you're switching your facility around quite often, it's a lot easier to do that with wireless than having to move wires around. Wired, again, is a little bit less expensive than wired. Wired is a little bit less expensive than wireless. But again, you've got that fixed data point, right? So you've got some costs when you're going to move things around or reconfigure your plant floor layout. The third option is using what we have what's called process monitoring, which is another product that builds upon that real-time concept. So again, process monitoring is a connection into your device that work center on the floor, but instead of just gathering things like uptime and downtime and cycle information, I'm now pulling in process information. So I could be measuring things like, temperature, stamping speed, all kinds of other various pieces of information that you're getting out of that PLC. So it's just another way of making that connection to gather real-time information. And then I call them the enhancements, but they're really the workhorses, the power tools of the real-time system. And those are things like ShopWorks, which is our shop floor data collection point, right? Some of you may be familiar with Shop Data, and if not, Shop Data is an older application that's still very relevant today. It's an interface that a shop floor user goes into to report things like rejects, to change that job over, to go in and report production if I want, explain why I had downtime or rejects, etc. It's just a data collection point, but it's designed for the shop floor user. ShopWorks is just a more modern web-based application that does a lot of the exact same similar functionality, but using a little more modern UX. And then WMS, I can accomplish a lot of those other tasks like production reporting, even reporting rejects, even starting the next setup using WMS. So those are tools that allows for that real-time data connection. So real-time information. So what is that? Why am I doing this? So it's connecting end-to-end data. So as I kind of mentioned before, there's two ways to power real-time. There's a signal method, again, that's taking data directly from the device, or there's a non-signal method where I'm using maybe ShopWorks or WMS to start doing some of that data collection. But that data collection is still providing relevant details into the production report and into other areas. And depending on how you want to use this real-time information, I can do some really incredible things. As you can see here, one of the things I'm talking about here is reporting production at the source. So what do I mean? If I'm doing real time, if I'm using the power of real time, and I'm using, let's just say, the warehouse management system, I complete a box or I complete a pallet of product, and I want to go ahead and transact that product, I can do a transaction that will literally go in, consume those materials that were used to produce that product, put that work in process or finished goods item, depending on what it is, into the system, and even collect the rejects. So that means at that moment in time, I'm making an adjustment to inventory, right? I'm taking out those raw materials, I'm putting in that finished good item, and I'm maybe doing some updates with rejects. And the beauty of that is it's providing me with some really powerful information on the back end of things, right? Because I'm doing that in real time, I have the ability to gather that lot information. So I've got tight lot information because I know exactly what material was in front of that machine at that point in time when I did that scan with that scanner to do what's called a real-time scan to inventory, right? That RT scan to inventory said, I know what job I'm running, I know what material I've got sitting in front of that work center, I know the lot number of that material at that work center. So when I put that part into inventory, I can go in and make those connections. The other beautiful thing with that then is I can see my current material status. So it's not 100% real time, like every single moment of the day, I know exactly where my inventory is, but every time I'm doing that RT scan to inventory, or I'm doing that floor disposition in ShopData or ShopWorks, I'm making those inventory adjustments. So if I want to see, every half hour or so, what's my status on this inventory? If something goes wrong, if I'm going to be in a position where I need to expedite inventory, or I'm going to look, okay, so it's that inventory visibility, which goes back to what I was talking about before. Inventory accuracy is really big in my world. And of course, the more accurate your inventory is, the more accurately you can plan for the things that go wrong and the things that go right. And you can be much more upfront and honest with your operations overall and with your customer. And of course, finally, that other information that's coming from the real-time information is I'm building that shift report, right? I'm getting that shift report built in real time and not waiting to the end of the shift or sometime further down the road. So let's go ahead and talk about, why real time? Because there's a way to do this today, right? I don't have to be running real time. I can do this with the power of a piece of paper and a pen. But why do I want to do it in real time? Well, I'm going to take the chaos of paper and I'm going to bring you some harmony in your operations. So jumping in here, let's talk about paper. What am I talking about when I say old school production reporting? So this is what's typically happening in a lot of environments if you don't have some type of connectivity between that work center and the production report in your ERP system and all those other pieces. I've got an operator, very wonderful person, goes in and attempts to fill out a form to say, here's what happened during my shift. Here's the job I ran. Here's the machine I ran that job on. I think the machine was up this amount of time, and I think it was down this amount of time. Not really sure because I wasn't really paying close attention. Here's how many parts I produced. Here's how many rejects. Oh, by the way, I had to call the maintenance guy once or twice, etc. So you've got this person who's doing the best that they can, filling out paperwork. Now, right off the bat here, I've got a skilled person who should be running that machine, looking for quality, doing all those really important things, and they're hecting in an old school, data paper pusher. Okay. So instead of, so I fill out this paperwork, and I'm going to take this paperwork, I'm going to give it to my supervisor. Now, the supervisor has their own form of challenges, right? First of all, they got to get all the forms. So everyone that was running production that shift, they got to go out there and make sure they get all the forms. Then they have to read the forms. Unfortunately, if that supervisor was my supervisor and they were looking at a document that I filled out, I wish them the best of luck. My writing is atrocious. My mother will tell you that, and that's one of the reasons that I use computers all day, because I can't, my writing's not very legible. So that supervisor is trying to decipher my hieroglyphics, right? Trying to figure out what the heck did Stephen mean when he wrote this out. Was it even the right job? I think Stephen was talking about a completely different job, which he wasn't even running. And then he's got to make corrections to the form, okay? So let's say you're the supervisor and it's after the shift. Well, of course, your people have already left, right? They're done for the day. They want to get the heck out of there and enjoy the rest of the day, enjoy their weekend, depending on where you are in the week. So now I've got to go in and try to decipher and correct mistakes on that form. And then on top of that, now my supervisor or someone else, it could be a data entry clerk, so there could be a third person in this mix, has to go in and do data entry. And data entry, as we all know, is fraught with mistakes. If I have a human being trying to interpret information off of another document and bring that information into the system, you're going to get mistakes once in a while. We're only human, right? So right there, I've got three people chasing paperwork. I've got my operator, I've got my supervisor, and then in my case, I've got my data entry person. There's a lot of overhead with that and a lot of non-value added going on. And like it kind of says here, this was great for the 1990s and earlier. Yes, there was some automation back in the 90s, and there was automation even earlier than that, but that's just not the way that you want to run your operation. You want end-to-end connectivity. You want that data entry to be as automated as possible and get that human being out of the equation and get that human focused on adding value to your operations. So let's talk about, what does real-time do, okay? So real-time really brings to you that machine connection production data, right? So what is the machine providing to you? So whether it's signal or no signal, non-signal, I'm getting a count of good parts and rejects, right? Because I'm entering that information in at the point of origin. I'm going in, and like I said earlier, I'm either scanning that using warehouse management, I'm using shop data and doing a floor disposition, or maybe ShopWorks. I'm reporting good parts then and there. I also have the ability to report those rejects, because you know what? If I'm reporting rejects in real time or as close to when they are happening, I can trigger signals throughout my organization and say, guys, something's going on. Something, I expect a reject once in a while, but also I'm getting rejects every couple minutes. Let's get that SWAT team out there and try to figure out what the heck is going on. Or let's not worry about the SWAT team because we're having a great day. Normally we've got some issues on this job and we're having a nice clean run. The signal also provides you some other details that you can also automatically populate that production report, right? You've got that uptime. So if the machine is cycling through, it's opening or closing depending on your process, right? I'm getting my uptime, but I'm also going to get some downtime once in a while too, potentially. Maybe I ran out of materials for some reason, which is a terrible thing to have happen. Maybe I had some kind of quality issue, so I shut down that machine temporarily to take a look at that and figure out, what's going on with that downtime. Maybe it was some other issue, the operator takes a lunch and there's not a person to replace that operator. So I want to see that downtime, because obviously downtime is extremely important and extremely costly. And back to those rejects again, depending on, the complexity of the machinery and how far you want to take things, the machine can actually help report the rejects as well, because maybe it has the capability to look at, that particular cycle and say, yep, these parts were good, or no, these parts were no good. And then what is the operator doing? The operator is going in and filling in some details in the background, right? They're potentially going in and saying, why was the machine down for 25 minutes? Well, it was down because I needed to take, it was lunchtime. Or I was down because I ran out of packaging materials to pack my parts in, etc. The other beautiful thing that real-time can do for me, depending on how far you want to take things, you could tie that in with advanced warehouse management, where based upon that cycle information and all that information that the system is giving into you, whether it's, like I said, it's signal or non-signal, I can be driving other activities in my organization. I could technically signal someone to say, hey, based upon this number of cycles, I want you to bring me more of this material, another coil of steel, another box, another whatever the case may be. So, and the other thing the operator's there for too is to tell the system, hey, I'm all done running job number 1. I'm going to go move over to job number 2. So I'm going to do a setup. So that's where the operator is doing their job. They're not doing that paperwork. We're trying to get them out of the paperwork business and into the operator business. What's back to this critical data now thing? I keep talking about that collection of data, right? That inbound, that inflowing information. So why is the critical data so important? Remember I talked about this before, but it's that live inventory. If I am doing that RT scan to inventory, if I'm using my warehouse management system in combination in real time, because I'm getting that connection between what's really running on the machine. So that's that real-time connectivity. I can plan and react in the moment, right? I know where my inventory sits. I know where my inventory is flowing into and flowing out of. And the other beautiful thing with that is I can also ship just in time because I'm getting that connectivity between the lot information, or I'm getting that connectivity to know exactly what materials were used during this particular production run at that particular moment in time. I have all that information, so I can do just-in-time shipping and not have to backfill that information after the production report because it's going to be sitting there. I have the ability to see what's going on from an operational data point of view. If I'm connected to the machine, I can see I have X number of machines down in my facility, or I have Y number of machines are running beautifully. Some are running a little slow. Let's get some resources out there and figure out why we're running slow. I can see where I am. I know where I am in my daily operations. And with that daily operational view of that data coming in via real time, I'm able to discover issues early, which I think is one of the most important things. Is all this real-time data is allowing me to do is I can figure out when I'm going to have a problem much earlier than I do normally would. So that's why that real-time thing there says insights now, not insert time frame here. And why do I have that with a big old red thing saying insert time frame here? Because depending on when you're doing that production reporting and you're gathering that production data, if I am waiting until the end of the shift, in some cases for some people, it may be the end of the week, which is even worse, or the end of the day. So I've got 3 shifts and I wait for the next day. I can have a lot of operational issues that I'm not going to be able to recognize until after that production report is finalized, as opposed to using real time to build up all that production data, to get all that information collected and collated into the system in a real-time basis, which makes a big difference to my operations. So that's the high-level overview of what is real-time and what's the difference between the old school method of paper versus using real-time. So I'm using that automation tools to collect that data. And don't forget, like I said earlier, there's 2 different ways to connect a machine, a work center, to the system. You're doing a real-time work center connection, but it could be signaled. And again, that means I'm pulling data directly off that machine with some operator input, or I'm doing what's called non-signal, where the operator is not doing a bunch of data collection, but they're providing the drivers that the machine would provide normally to provide some of that data. So I'm doing that RT scan to inventory, and I'm getting that production report built out. I'm getting those rejects, but instead of writing them down on a piece of paper and waiting and waiting and waiting, I'm getting all that information built up in real time throughout my shift, throughout the day, and throughout the year. So now that I'm getting all this beautiful real-time information, what is that going to do for me? So let's talk about continuous improvement in OEE, okay? And what does that mean for me? So removing waste and finding the value in my production floor. So this is all big in the continuous improvement process, right? And we all know what this is. Not going to spend a lot of time out there on what this really means, but it's the plan, do, check, act. It's that vicious, very important circle that you make a plan, you do it, you check, you act upon the results, you make improvements, you plan it, you do it, you check it, and you act it. You keep doing that over and over and over again to continuously drive improvements through your processes. And that's basically what continuous improvement is in a nutshell. So let's talk about where OEE comes into play. So OEE it means overall equipment effectiveness. So it's about how much bang am I getting for my buck with that piece of equipment? And there's 3 key drivers of OEE. It's the availability, it's the performance, and it's the quality, right? Those three pieces make up what's called the overall OEE number. So let's dig into each one of those and kind of pick apart a little bit. What does availability mean? What does performance mean? What does quality mean? So from availability, that means, was the machine available to run? Was that machine actually up and running and making parts? And with that, there are really two types of downtime that's out there in the manufacturing environment. There's planned downtime, and these are the good things, right? Planned downtime means I'm going to be doing some maintenance on the machine. I'm planning an MRO event, right? I want to go in, I want to, change filters, maybe lubricate, maybe clean, maybe do some of those other types of operations, that preventative maintenance stuff that allows my machine to run smoothly when I want it to run. But on the negative side here for downtime, there's that unplanned downtime. And that's what we talked about before, where something went on my production floor that is preventing me from running that machine. And again, that can be anything from a people problem, it could be a materials problem, it could be a machine problem, or it could be something as crazy as the power went out, right? Something happened to me that I am not available, that machine is not available. So my very first OEE metric is around availability. And the biggest thing that I am looking for is the most availability possible. I want that machine to be up. I want that machine to be running and not in a downtime situation. And again, like I said before, planned downtime is not necessarily a bad thing. That's putting in the effort up front to make sure that my machine will continue to run long term throughout the production cycle. Performance. Three big things that come into performance, right? I'm looking at my standard cycle time. I go in, I build my bill of manufacture, I build my routing, my processes, whatever you would like to call it, and I come up with a standard cycle time saying that, hey, when I run this particular part on this particular piece of equipment, it's going to run at this standard cycle time. This is my expectation. Now, the difference is, of course, is your actual cycle time, because you know what? Sometimes our standard is one thing, and sometimes our actual, it floats around that standard cycle time. It's a little bit faster sometimes, it's a little bit slower sometimes, and it really depends on that process. But what we're really driving for is that standard cycle time. And the other piece that truly affects performance, though, is I can't have good performance if I'm not making good parts. So those three drivers contribute to what becomes my overall performance of that piece of equipment or that work center. And then finally, breaking it down to the last piece, which is simple as can be, it's good parts versus rejects, right? I cycle X number of times. In a perfect world, I would have 100% good parts, so my quality would be 100%. But we all know that there's this problem called rejects. It's inevitable in any process. Something could potentially go wrong, and that rejects that happens during my manufacturing time, that's going to drag down that quality number, though. So those three things coming together, availability, performance, and quality, that's what sets the foundation for your overall equipment effectiveness. And what we're trying to do is we're trying to drive those to 100% availability, 100% performance, 100% quality, which if all three of those factors equal 100%, that means your overall OEE is 100%. Now, expectation is 100%. Is that realistic? Probably not. We all live in the real world, but still, that's our driver, though. That's where we want to head. So let's talk a little bit further here about, why is OEE so important? The biggest thing is for a lot of our customers, and the way I look at this a lot of times is this: it's your North Star. Okay, it's your guiding star, because if your OEE is in the upper 90s or hitting, even if you're really lucky, hitting that 100%, that means you're hitting your metrics, right? That means all those wonderful plans that you made to supply your customer with parts, to reduce your inventory, to have that machine cycling correctly, to have, the employees actively working and adding value. That means if all of those things are hitting on all three cylinders, your performance, your availability, and your quality, that means your North Star metric's going to look pretty darn good, and we're going to be hitting things. But you can't always have that. So what do we need to do? We can drive that down to compare it at different levels. Maybe it's the same product running on two different machines. I can compare, why is my why is my performance better on X machine versus Y machine? I can look at those two machines as I start to build up that OEE information over time and go, hey, why is there a difference? Because technically speaking, these two machines should be exactly the same, but there's something different, and maybe we can dig in and figure out why these two machines aren't producing at the same rate that they should be. The other thing I can use that OEE for is I can drive automation in the system. Okay, I can go in and build alerts inside the system and say, hey, if you see the OEE number slip to this percentage or this percentage, at this percentage, call out, the supervisor. Maybe there's something going on that the operator needs a little of assistance. Maybe if the quality side is going a little off the deep end here, let's go ahead and call out the quality team and the engineer. Let's dive into this problem, because making bad parts for the next 30 minutes, 40 minutes, 50 minutes, whatever that case may be, that's no good to us. Let's automate. Let's get that team out there. Let's get those resources at the source of the problem as quickly as possible. And that's where that automation comes into play, and it makes a big, big improvement. And again, that information is being driven in real time by both the information coming from the real-time system and then looking at the bigger picture for OEE. Because you can have plant OEE, I can have work center OEE, I can have cell OEE, I can have all these various ways of looking at that overall equipment effectiveness. And then again, in your continuous improvement projects, right, you're going in, you're improving the tooling, maybe you bought some automation, maybe you did a complete overhaul on this piece of equipment, or a complete overhaul on a bunch of pieces of equipment. You want to see if that's made a difference in your operations. Well, looking at that OEE number will prove to you whether or not your continuous improvement projects are achieving the end results that you're desiring, right? We're always trying to continuously improve. We're wanting to be, a little less waste here, a little bit of energy efficiency here. Let's always hit those customer numbers that we're driving for. Let's get those bonuses out to those employees. Let's make the money, and let's make sure that everyone from end to end is happy. And we can do that by proving out using OEE to say, yep, that investments that we're making on that production floor, they're paying off. They're getting us to where we want to be in the long term. So let's do a little bit of a wrap up here. So covered a few things here and there. Why real-time production monitoring? What's the benefits of this? Why would I want to make this kind of investment? What do I get from this kind of investment? And remember, really what we're doing here is we're taking three things and we're bringing them together. We're bringing together that machine or the work center on the production floor. We're tying it into the system. So we're tying that information that you're getting from the production floor directly into the ERP system. We're tying that into the manufacturing execution system. We're getting the data we need to make decisions on how to execute our manufacturing plans, how to execute our purchasing plans, and how to, overall big picture, how to make sure that we're executing our commitments to our customers on the other side of this. And then finally, with that third most important piece in my mind is that people asset. Taking the person out of the equation for doing data entry and those clerk-like activities puts their value where it needs to be. Their value should be on improving those processes. Their value is on making sure that machine is running as best as possible, or those parts coming out of the machine are coming out correctly. They're able to focus on quality and good product as opposed to focusing on paperwork, which is just a major waste of time, as we all know. If you haven't gotten the theme yet, you can tell I'm not a big fan of paperwork. I don't like doing expense reports, and I don't like filling out production reports either. So what are the two major components of real-time? These are the major components, right? It's that work center. It's that ability to connect something on the floor into the ERP system. And then taking that to the next level, it's that direct machine connection. If you've got the capability to do that direct machine connection, you're just taking that real-time information up to the next level, right? You're making that investment in a piece of hardware that allows you to pull directly the signals of, uptime and downtime and cycle time, et cetera, from that machine. The other really big benefit of all this, and we've talked about this throughout this, it's that reduction in labor and inventory costs, right? I'm focusing in on the important things. I don't have to bring in as much materials because I know that if I'm going to have a problem, I'm going to know that sooner. I'm going to know that faster. And then the other big thing, of course, is you can see how this real-time information is going to change and improve your bottom line. It's focusing in on, making the right decisions based upon information in real time. Like we talked about over and over again, waiting to the end of the shift or the end of the day, or if it's even that bad, maybe the end of week. Too much has happened and you cannot go in and dig in deep enough and make those execution decisions fast enough when that much time has passed by. Real-time information allows me to know I've consumed this material, I produce this product, I can ship this product, and I can fulfill a commitment I made to my customer. Whether that customer is the external customer, or that customer may be another work center in my facility, or in a sister facility saying, hey, I got to supply you something. So let's keep that supply chain moving nice and smoothly. And that's pretty much what real-time is all about. So that is the presentation here. I believe we are moving into the Q&A session here. So Leah, I'm going to bring you back online with me here. I'm sure there's got to be some questions out there, potentially.
Yes, we do have a few questions. Thank you so much, Stephen. Great job on the presentation. We will now take some questions from the audience. Just a reminder, make sure if you do have questions to submit them in the chat area, the question area on the side, so we can get those answered. So it looks like we have a couple questions around OEE. One of them being, how do you calculate OEE?
So OEE is, there's a couple different calculations that go into calculating OEE factors. So, and one of these days I'm going to stick the slide in here so you guys can see the equations with me. So the availability is pretty simple, right? It's basically looking at your shift up hours plus shift down hours minus your planned downtime hours. Okay, so what I'm saying is you've got how many hours you were actually up, plus how many hours you were down minus your planned downtime hours divided by your shift up hours. Okay, and that's going to give you your what's called your availability factor. And it's a pretty simple equation, right? So if I ran for 7 hours and then I ended up looking at that, and I had 7 hours plus 1 hour of downtime. If I divide that in there, right, I'm looking for an 8-hour day. Well, then I only did, and I just blanked out on this, I only ran at 80%, because that would be 10 hours in the shift, right? I only ran at 87%. Okay, so that's an example of availability, and I think I just did the math wrong on that one too. The other one is, let's talk about, if we want to talk about, maybe let's talk about performance, right? Performance is fairly simple. How many parts did you get in the shift divided by how many shift up hours? And then looking at, what should you've gotten? So it's basically, what did I get in that shift? So I got 1,000 parts over 8 hours, right? I'm taking that number, I'm dividing it out, and then I'm dividing it again by what should I have gotten during that shift. And that's going to be multiplied, obviously by 100 to get your percentage. So that's going to get your overall performance. And then finally, way down there at quality, this one's even easier. This is my favorite one. It's really simple. How many good parts did I make divided by how many parts did I make overall? So it's good parts divided by overall parts, and that will get you your overall quality. And then again, you take those three numbers, you bring those numbers together, and you get your OEE number. Hopefully that answers the question.
Yes, thank you. Another question is, why don't the OEE metrics update throughout the run in real time if it's all connected and visible?
The OEE numbers should be updating throughout the entire production run. If real time is running, that should be happening. You'll have a couple different OEE numbers though. You'll have your what's called the real time OEE numbers, which if you're using shop data or shop, and in the very near future here, ShopWorks, that will be in that very the job summary information. And then from there, you'll have a running total for your shift, your day, and then and I think the other one is actually for the particular work order, if I'm remembering those three places correctly. So that information should be updating in real time. Now it isn't calculated every couple seconds. There is a little bit of delay as depending on how your system's set up, if you're using real time and how you've configured the real time server, etc. There could be up to a 2-minute delay, again, depending on how you configure your system, on how often that information is being updated. But it should be being calculated in real time or as close to real time as possible.
Okay, great, thank you. Another question, is there any easy way to compare runs?
So there is. You can use, one of the good ways to use that is the work order history tool is one place to do that. There's also some reports that are built into the system that you can use to compare. And the way that I've typically done this in the past is I compare two different work orders. I want to look at a full production run, right? I want to look at a work order one ran, a month ago. I'm just bringing this job back in. I ran it this week, and now I want to compare those two. So I look at those two production runs. The best place to kind of see that history, though, is what's called the work order history module in real time, and that will show you, when were these runs executed, what was the basic OEE information, et cetera. And then from there, you can dig into the details and start driving into, was my OEE good? Okay, but my weakness was here, maybe in performance, just as an example. Then you can drill in further, and look at, well, what was the performance problem? Oh, it looks like I had a lot of, X, Y, or Z was going on, or maybe my availability was bad. It looks like, on my availability side on the second production run, I had a lot of material out issues, or I had some people issues, or whatever the case may be, right? That's how I can go in and start digging into those numbers to compare. I can compare shift to shift. I compare production run to production run. And actually, if you want to take it one step further, you could actually compare year over year if you wanted, or quarter over quarter. It's just a matter of, how do you want to build out that information and pull that into the reports that are available. What else you got?
Awesome. Another question, how do you record a first pass reject?
So first pass rejects can be done a couple different ways. The way that I've typically done them, though, as that machine is being spun up, right, you're going to have some cycles going through. And depending on how you're connecting, is it a connected machine or a non-connected machine? Different ways to do this, but if it's a connected machine, you might get a cycle or two. And what typically happens is the operator will go in then and say, these are my startup shots or my startup cycles. I'm going to go in and report those rejects as that, and they can be classified differently so that when you're looking at reject reports, that these rejects were related to, your setup cycles versus, your first couple, you're dialing in your processes here. So I want to have those dial in parts, and then finally, I'm making parts now. So depending on how I want to classify those during reject reporting, I can go ahead and have those show up in different ways inside of my reporting. What else you got?
How can real-time be used in assembly one bonds?
So currently, there is limited linkage currently today with assembly one. We are exploring the opportunities to see how do we bring in real-time information. Remember that assembly is initially based upon, I've got a part, I'm going to go to workstation 1, workstation 2, workstation 3, 4, 5, etc. And a lot of those processes were initially envisioned as being very labor driven, right? It's a human driven process. What we are looking at exploring is, can we take those situations where I do have a machine that's running and I've got a situation that would work brilliantly if it was a generic BOM or an injection molding or something else, other manufacturing type that's out there that we support. Would it, can we bring that kind of technology in and start bringing in that production data so we can get, the shift report, the uptime and downtime information that we're looking for, the preventative maintenance data that real time can drive, as well as, the good parts of the rejects and those other pieces. So that's something that we are actively exploring on, how do we bring that in so that we can populate the assembly production style with the relevant production data from real time.
Awesome. Can you apply real time in a CNC environment?
So there are methodologies for doing some of that. The difference is that CNC tends, and it depends, okay? A lot of the way that real time was initially geared, and again, this is something else that we're exploring, is how are we going to make that connectivity with a CNC machine where you've got a little bit longer cycle time potentially. Not always, but you do have that. So at the moment, what we can do is bring in the information, say that, hey, we did complete a cycle, but you can still use real time though from a non-signal point of view to drive those production reporting metrics. I can still go in and say, yes, I made a couple of parts, do that RT scan to inventory. If I've got rejects on that or I've got material usage issues, etc., I still can use real time to drive that. I may not necessarily be getting the information directly from the machine, but I'm getting it through those tools on the shop floor to build that production data so I can start driving towards OEE and some of those other things. And again, that's something that we are, just like the assembly data question, not assembly data, but the assembly manufacturing types methods, we are exploring how do we properly tie that connection back in between the machine and the system if you want to do a signal real time.
Awesome. Well, thank you so much, Stephen. It looks like that's all the questions we have for today.
Thank you for viewing this pre-recorded webinar. For more information on DELMIAworks products and services, please visit 3ds.com/DELMIAworks.